In this StatCrunch video, what we're going to be doing is some survey analyses. And to start us off with, we're going to use a scale that measures a variable I think most people will be familiar, and that's a type A personality. So you can get this survey information if you want to follow along in the video by going into Resources in StatCrunch Labs. This is Lab 5 survey analysis, and I've just uploaded this type A personality survey. So if you open this thing up, and actually I have it over here in an Excel file, what you'll see at the top is each question in its entire wording. These are all pretty short items, but you can read them here if you like. And then before it's or below, it's all answered on a 1 to 5 scale, with 1 meaning strongly disagree, 2 somewhat disagree, 3 somewhere in the middle, 4 somewhat agree, and 5 strongly agree. So much like the scales that you guys are using. And you'll notice that a lot of these have to do with things that are very much a part of type A personality. So things like, I feel angry when matters get out of my control, because type A people like to be in control all the time. But there's also items that are reverse scored. So things that are indicative of low type A personality, or basically, maybe we call it type B personality. That's what some researchers call it, but a very laid back approach. So this is a reverse scored item. I don't get stressed easily. So if they answered high to that one or strongly agree to that one, it actually means they're low in type A personality. Number 3, I find myself taking on more than I can handle, classic type A. I find it difficult to wait for answers, another type A type of personality statement. And then this one's another reverse scored one. I am a patient person, so that needs to be reverse scored in our scale. My work must be detailed. That's another type A personality statement. Another reverse scored one, I am not easily agitated. It's very difficult for me to relax. That's a regular type A statement. And then I tend to procrastinate. That's a very non-type A thing to do. So again, another reverse scored one. So here we have basically we have 5 type A personality items, like this one, difficult wait for answers, and the other 3. And then we have 4 reverse scored items, which is I tend to procrastinate, I'm not easily agitated, I'm a patient person, and I don't get stressed easily. So what I've done here is I've opened this up into StatCrunch, and again, it just looks exactly the same. And the first thing we need to do is reverse score the items that need to be reverse scored. So like this one, I don't get stressed easily, I'm a patient person, I'm not easily, I'm not easily agitated. And this one, I tend to procrastinate. So if you remember back from lab 3 and 4, we reverse scored items in those labs as well. So here what we're going to do is, in order to reverse it, we're going to flip the scale of it. So we're going to go to Data, Compute Expression. We're just going to do these one at a time. So to build up our expression, first we need to put in the item that we need to reverse score. So we'll work with this one first. I don't get stressed easily. And since this is on a 5-point scale, what you do is you take the item and first reverse it, mainly times it by -1. So if someone answered a 5 out of 5, they strongly agreed with the statement, I don't get stressed easily, this will convert it to a -5. And then you're going to add 6 to it. And again, like in lab 3, since this is a 5-point scale, we'd add 6. If you were dealing with a 7-point scale, you'd add 8. If you were dealing with a 10-point scale, you'd add 11. You always just add on 1 more than what the scale total score is. So in other words, if someone was a 5 out of 5 and I don't get stressed easily, really they're low in type 1 personality. We want to convert that 5 into a 1, and this does exactly that. First it flips it to a -5, -5 plus 6 equals 1. Similarly, if someone answered a 1, like this person answered a 1 to I don't get stressed easily, strongly disagreed with it, we want to convert that to a 5, flipping the scale. This does that same thing. It converts it first to a -1, and then adds 6, converting it to a 5. So this is the equation we're going to use for all those items that we want to reverse score. So go ahead and hit OK and compute. And we're just going to do that with all of these as we go along. And actually, if you edit this, you can go back to this statement. We can build it in here. So in fact, we can just take this exact same computation and just apply a different variable to it. So this one, I'm a patient person. That's the next one we need to do that with. So we hit OK, compute. And then we can do it with the next item here, which is I am not easily agitated. So you want to add that one in, hit OK, compute. Go back to edit, and then we have one more to do. And actually we can take it out there too. And then in our expression, this is the last one, I tend to procrastinate. OK, compute. So now we have all 4 of those reverse scored items now with a reverse scored basically version of that item. So we might want to do to denote this and make sure it's really easy for us to figure that out is we might want to rename these. So what you can do is take the whole thing, and I could like to just sort of skim over, let's see. Actually, what we can do is just take the whole thing and just put in R. Well, actually we don't need quotations. I don't get stressed easily. Just we started with an R, so we know this is the reversed form of it. This one's I'm a patient person. So again, we can go R, I am a patient person. This one's I am not easily agitated. So R, I am easily agitated. And the last one, I tend to procrastinate. So we put in an R, I tend to procrastinate. So again, the reason that we're doing this is now we have each version of the scale, or each version of each item, where a 5 out of 5 means they're high in type A personality, and a 1 out of 5 means they're low in type A personality. So with these items, this one, I don't blah, blah, blah. I am patient, I'm not easily stressed or agitated, it's very, or I tend to procrastinate. All of these we have now a version of them. We're getting a 1 out of 5 means low in type A, a 5 out of 5 means high in type A. So now we have a version where they're all pointing in the same direction. So now we can start doing some reliability analyses. And one type of reliability analysis we can do is called a split half reliability analysis. That's basically when you take the first half of the scale and then basically make a total score out of it. So, 1 plus 2 plus 3 plus 4 plus 5. And then the second half of the scale, here we only have 9 items total, so the second half can just be 4 items. And we're going to make a total scale out of that, so items 6, 7, 8, and 9. And then we're going to run a correlation between those total scores just to see if the first half of the scale correlates highly with the second half of the scale. It's not a perfect way to do reliability analysis, and we're going to figure out a little bit more of a complex way here to do it in a bit that is a little bit better, called Cronbach's alpha. But a split half method is very easy to do, and it gives us a rough view of how well the scale is holding together as a whole. Does the first half of the scale jive well or correlate highly with the second half of the scale? And really it should. Now, when we're doing this, we're creating our scale totals. We want to only include the reversed forms of each of the items that we reverse scored. So in other words, when we're adding up 1, 2, 3, and 4, we'll do 1, 2, 3, 4, and 5 for the first half. We don't want to include this version. I don't get stressed easily. We want to include this version, the reverse scored of that. Same thing with 5, I'm a patient person. We don't want to include this one, we want to include this version of it. So whenever we're working with our scale from this point on, we really only want to include the reverse scored item parts of it. And actually one thing you can do, and you know what, let's go ahead and do it, just because this will make it a little bit easier for us to work with so we don't get confused. We can actually edit out those basically items or columns that we're not going to work with anymore, the reverse scored ones. So let's go ahead and do that. Let's go item delete, item column delete. We're just going to get rid of all these ones that we reverse scored. So I don't get stressed easily. And again, you can hold down Command or Control. Command if you're on a Mac, Control if you're on a Windows, to select more than one. So I don't get stressed easily. I'm a patient person. So these 2 items right here, let's see, I am not easily agitated and I tend to procrastinate. So those are all the items that we want to delete because now we have the reverse scored forms of them. So we can go ahead and hit compute. And there we have it. Now we have just 9 items, and now they're all just the version of the item that we want, where 5 means high in type A personality and a 1 means low in type A personality. So now it'll make the rest of it pretty easy. Okay, so now we're going to do that split half reliability. Again, we're going to create a total score for the first half of the items, here 1 through 5, and then another total score for the second half, here items 6 through 9. Or on yours, since you're going to have 10 items total, 6 through 10. So in order to do that, we're going to do another computational expression. This one's pretty easy. All we're going to do is just add them all up. So we'll take the first 5 items, make sure to hit the addition key in between each of them. So we're just selecting each column, adding it in. And then the last one here. And then we're going to go ahead and hit OK and compute that. And now we just have a total of all of them. And again, we can just jump back to this menu here just by hitting Option Edit. I'll go ahead and delete all this because we're going to add in totally different items, but now we're going to add in all the other items. And it doesn't matter if you're comparing the reverse scored ones with the non-reverse scored ones. You can really pick, you can split your scale any way you want to. I'm just keeping it easy with the first half and the second half, but you can even do it randomly if you want to. And compute that. There we go. So basically, and it doesn't matter that this column is going to have higher numbers because we're adding 5 here, and this column is going to have lower numbers relatively because we're only adding 4 items here, because what we're going to be doing is correlating the two. So it doesn't matter that, one might have a total of, let's see, 22 seems to be high for this one, and this other one would have a total of this one should have a total of about 25 tops, this one have a total of about 20 tops, because all correlation does is it checks to see if someone's scoring low on any particular set of items, so these 5 items, they should also score relatively low on these 4. Same if they score high on these 5 here, they should score also high on these 4 here. So it's all about relative high and lows. So let's go ahead and run a correlation there between these two. So it's stat, summary statistics, correlation, and then we're just going to put in these last two that we have. There we go. And we can put it any order we want to. We could, just easily do it this way. So we want to display a two-sided p-value just to see if it's significant or not. We get a correlation whether it's significant and hit compute. So what we should hope to get is a significant positive correlation between these two parts of the scale. To get a significant correlation, all you have to have for a p-value, and that's this thing in parentheses here, this number of parentheses, is a 0.05 or below. So this is definitely a significant correlation because it's well below 0.05. And we want that correlation to be positive, basically that the first half of the scale is positively related to the second half as we'd expect. And indeed it is. Otherwise this would be a negative number. So just as expected, we have a positive correlation here of 0.25, around 0.25, and it's positive, or it's significant at p equals 0.0008, so well below 0.05. So that's one way to just quickly check reliability. And so far, this scale looks okay. Now, I would have expected a correlation a bit higher than 0.25. That's kind of a weak correlation. And since all these items are trying to assess the exact same thing, I would have expected a correlation more around 0.5. But still, it's positive, it's significant. So in that way, we're on the right track. At least the atoms are somewhat hanging together. Now, one of the problems with this type of reliability is what if we'd split it a different way? Perhaps if we'd added them items 1, 3, 5, and 7 and compared them to 2, 4, 6, 8, and 9, because we have to pick up that extra one, we might have gotten a very different correlation. And instead of having to run, different correlations with every single possibility of splitting it, one thing we can do instead of doing that is what's called a Cronbach's alpha. So what a Cronbach's alpha does, and it requires a little bit of mathematics, what it basically does is it's a quick way to analyze the sum of correlations between all the different items. So the mathematics, in a way, what it does is it compares the variance, or basically whether someone is high or low in a particular item, with the variance of all the other items, whether they're high or low in all the other items. And then it takes that correlation and averages it across the correlation between item 2 and all the other items. So is the variance, whether someone's high or low in item 2, similar to how high or low they are across all the other remaining items? And then it averages that correlation along with, whether item 3, whether it's high or low, and whether that correlates with how the other ones are higher and low. So basically what it's doing is it's running correlations between each individual item and all the remaining items, and then averaging across all those correlations. And thankfully, when we do the equation here in a sec, you'll see that it doesn't require doing all that. The equation is a much more simplified version of that, but in effect, that's what it's doing. It's comparing the variance, whether someone scores high or low, in each individual item with the variance of the rest of the scale. So let me go ahead and close this out. So that was split half reliability. And also, once you have that, you can delete these two columns. We don't really need them anymore. So just for the sake of making it really easy to tell what we have and what we need. So we'll go and get rid of these. There we go. What we're going to do for Cronbach's alpha is we're going to use this little equation. Let me bring it over here. Oh, my computer is frozen. Ah, there it goes. Okay. Okay, so we're bringing this little equation in here, and I just put this in a Word document. You can write it down somewhere if you like, but it's a pretty simple equation. It involves basically multiplying two fractions together. So this first one just involves the number of items minus the number of items minus 1. So in this case, we have 9 items, so this would be a 9 over 8. And then you're going to times that fraction by 1 minus, and this is where it gets in a little bit of the mathematics, but what we're going to do is calculate the variance for each individual item. Well, actually, we're going to have StatCrunch do that. And that's we're going to then sum all those variances together, because that's, of course, what the sum sigma means. And then we're going to divide that by the variance of the item totals. So to create this, to calculate the variance of the item totals, we're going to actually create another variable that's the total of all the items, just like we did before with the total of items 1 through 5 and 6 through 9. This time we're going to do it all the way 1 through 9, get the totals of all the items, and then calculate the variance of that and divide it here. So what we're going to first do is create this variable, because this is the only one we so far don't have in our data set, is the variable that is the total of all the other variables. But again, that's pretty easy to do. Basically, it's just the sum of all of these. So we're going to go to Data, Compute Expression. I'm going to build this. And of course, it involves just adding up all the columns. So we'll go ahead and do that now. There we go. So we've added up items 1 through 9, hit OK, and hit Compute. We can go ahead and close this. And actually, just so that I'm aware of what this is in the future, I'm going to go ahead and rename it Total, because it's just the total of all 9 items. So now what we can do in order to get these two things right here, which we need to calculate, we need to get the variance of each individual item and then add them. And then we need to just get the variance of this one totals column right here and divide that. So to do this, we'll go, basically we need the variance of all these. So that's under actually summary stats, columns. And we're just going to add in all the columns. Actually, if you hit Control A, I guess that doesn't work because that selects everything. Never mind. So what we can do is just hit the first item, hold down the Shift key, and then hit the last item, and it'll put them all in there. Or you can just hit the Command key or the Control key and select each one individually. But holding the Shift key and selecting the first one, holding down Shift key and selecting the last one, that's going to select all of them. And the only thing we need about all these is their variance score. So we're going to go ahead and hit Compute. And this gives us the variance of all these items. So what we can do, I'll put this over here, is we can use these variances in our equation. So one thing we can do also, let's see, it's not going to let us just select these out. But one thing we can do is, if you have Excel, a really easy way to do this, and remember this is just our Excel file with all the survey items, I'll just use this. I'll put in variances just to remind us what this is, but I'll just copy and paste all these variances in there. Because basically we're just going to take these and create a sum total of them. And rather than doing that by hand, which we can do if you have a calculator, it would probably take you about as long as doing this. But this is a nice way to make sure that you absolutely don't screw up anything on the calculator. And also you can include the entire number all the way to the maximum amount of decimal places this way, and not be, again, worried that you're going to screw that up with a calculator. So now we have all the variances. We can create the sum total here just by, in Excel, you hit =, sum, open parentheses, and then select all this, close parentheses. So you have equal, sum, and in parentheses, put in all the different variances we have here. We have 9 variances. We hit enter, and there's the sum total of variance right there. So now that we have that, we have everything we need for this equation. And actually, I'll go ahead and shrink this down a little bit. Actually, I can do it like this, and then just scroll over here. There we go. And if we open back up this Word document, I'll go ahead and do the calculations in here. And again, you can do this on paper. I'm just trying to do it in a way that you can see everything I'm doing. But I'm just going to take this equation. We'll copy it down here so we can keep this as reference. And again, all this is the number of items we have. Here we have 9 over 9 minus 1. And of course, for you, you're going to have 10 over 10 minus 1. And then here, we're going to have the sum total of all of our variances for each item. And we just learned that that's 10.3299575. You might say, well, do we really need all these decimal places? I say try to keep them in, especially for something that's a pretty short process. You can go ahead and do that just to make sure that you're getting a really exact alpha number, or Cronbach's alpha. And then here we're using the variance of our total scores right here. So that's going to be 20. There we go, 20.959423. So then you can just calculate this. Actually, let me bring up a calculator just to show us how we do that. And I'll kind of keep it in stages here just so that we can see each stage. So for this first part, we just take 9 divided over 9 minus 1, which is 8. This first part is going to be, let me see if I can just select that. There we go, 1.125. And then the second equation here is 10.3299575 divided by 20.959423. Make sure I entered it correctly there. And so that's going to come in here, and it's going to end up being a 0.49285505. You know, we'll kind of end it there. That's a lot. Anything beyond that, I don't think we're going to get much more exact, especially at this late part of the equation. So now we can take this number, minus it by 1, and actually kind of a cheater's way of doing that, since we already have it in our calculator, we can actually just hit minus 1. It'll end up being negative, but we'll just use the positive form of it. There we go. So basically, the last equation that we need to calculate, put that in, is 1.125 times 0.5071449. Again, I'm just showing all the steps. You don't have to show your steps as long as you end up with the equation at the end. And again, I already have that number in here. It's just negative, so we can turn that positive by just timesing it by a -1. How do you do that here? Is it 1 negative? There we go. Times it by -1. There we go. There's the positive version of it. And then times it by, oops, it would be, oh shoot, did I just lose it? Oh, that's the beauty of this sort of thing. This is why I like using a pocket calculator as opposed to the Mac version or the Windows version. That's okay, we'll just type it in. 71449, there we go. So basically we got a Cronbach's alpha equal to 0.57. And here we can just round to the nearest 100th place because that's how we report in APA format. And so just to, you'll probably know this from the lecture about it in the measurement theory lecture, but that is a Cronbach's alpha that's a bit on the low side. It's not quite, quote unquote, acceptable. An acceptable Cronbach's alpha is 0.7, so we're not too far away from it. It needs to increase by about 0.13. But basically, what this means is that some items in our scale are not maybe measuring the same thing as the rest of the items. They're not correlating with each other quite as expected, as it would be if we had a Cronbach's alpha of 0.7 or higher. But one thing is a nice thing to just check to make sure that when you're doing Cronbach's alpha calculation, you're always going to get a number somewhere between 0 and 0.99. And so since we got something in between 0 and 0.99, that's a good indication that we did everything right in the process. So if you end up getting a number that's really off, like it's negative or it's above 1, you've clearly done something wrong in the equation, and you want to make sure you check the steps over again. So basically, we've calculated the split half reliability. We've calculated the Cronbach's alpha, and both indicators show that our survey is somewhat reliable. So the split half show that the first half of the scale and the second half of the scale is positively correlated and significantly correlated as expected, although it's not quite as high as I would have hoped, because usually you're hoping for a correlation of about 0.5 between the 2 points of the scale. And the Cronbach's alpha showed that our inter-item reliability of how well each item is hanging with the rest of the scale is a little bit below acceptable, which would be a Cronbach's alpha of 0.7. But that's what happens a lot of times when you create a new scale. And this scale was actually, this isn't a very well-validated version of the Type A personality scale. This is one that some students created. But still, actually pretty good considering that they created a completely new scale, and split half and Cronbach's alpha show that it actually is hanging together okay. It's just not quite at that acceptable level yet. So basically what we've done so far is we've created reverse scored items. Of course, these are the last 4 here. We've done the split half reliability. We've done the Cronbach's alpha reliability. So now what we can do is basically figure out the mean and standard deviation for our total scale. So what we can do here is now, instead of creating a total of all the items, we're going to create an average of all the items. So that basically if someone scores a 5 out of 5 on the average, it means that they're the highest anyone could possibly be in type A personality according to this scale. And if they scored a 1 out of 5 on all these, it means that they're the lowest they could possibly score on all of these scale. So since we already have their total scores here, really we can just take these total scores and divide by the total number of items. So we don't have to create a long equation again where we're adding them all up and dividing by, in this case, 9, so we have 9 items. We can just take this one variable and divide by 9. So again, we're going to go to Data, Compute Expression, Build, put in totals, and since we have 9 items, we're just going to go divided by 9. If you have 10 items, you're going to go divide by 10. So go ahead, hit OK, compute, and there, and just get rid of this, there are all our averages. And as you can see, most people are kind of around the middle, kind of around 3 is what we'd expect. And that's probably because most people are somewhere in the middle when it comes to type A personality. They're not extremely type A, and they're not also extremely low in type A. They're somewhere in the middle. And that's actually a good sign that we're measuring a real personality variable. So one of the last things we want to do is just to see what is the actual mean and standard deviation for people on this scale. So here we go to Stats, Summary Stats, Columns. And the only thing we need is the mean, standard deviation, and we're just going to select the last one here, which says total times 9, but that's just the average of all the items. Hit Compute. So here we have the mean, and it's right around a 3, and on a 1 to 5 scale, 3 would be exactly in the middle. So again, that's a good sign that most people are right around the middle. But also we have some variability, about a half point in variability, which is also pretty typical. So actually, those are good indicators that we're probably measuring something stable, something that's akin to personality, and probably this variable will be normally distributed if we took a look at the distribution. So that's what we're going to do next, is actually look at the distribution of this to see if it's somewhat normally distributed. So to do that, we're going to go to Graph, Bar Plot with Data, and we're just going to select the average again. And this time, we're going to leave everything alone because all the presets are perfect. Hit Compute, and then it's going to do this very helpful thing where it says, whoa, I love this, whoa, we have lots of unique numerical values, because we do, we have lots that end in 0.333, 0.222, sometimes you'll get really odd ones in here. And so what it's going to ask is, do you want to bin them? And what that means is it's going to bin or put all like categories into one category. So usually what this does is it bins things by sort of wrapping them into 10% chunks. And in this case, what it means is it would bin all the ones from 1 to 1.5 together, all the ones from 1.6 to 2 together, all the ones from 2 to 2.5 together, and so on. So go ahead and hit OK. As you can see here, that's exactly what it does. Now we actually didn't have anyone with a 1, so it just started from 1.5 to 2, 2 to 2.5, 2 to 0.5 to 3, and that's perfect. That's how we want to look at our data. So in this way, is this normally distributed? In some ways it is. The peak is right in the middle. So in that way, it's pretty normally distributed with where the central tendency is, or where the mean is. And we can see that here, that the mean is right around a 3. But there are clearly more people along the left side of the center, basically low in type A personality, than there are people above center who are high in type A personality. So in this way, you could say that it's somewhat normally distributed, but there is somewhat of a, in this case, a negative skew, because we're getting more items on the negative side than on the positive side. So, and there could be different reasons for this. One probably very plausible reason is that this is kind of a younger age group. This was all freshman college students. So younger people tend to be less type A in general. So in that way, it's probably not too unexpected that we didn't get too many who are really, really strong type A personalities. But anyway, just to summarize everything we've done, so we have the total scale in StatCrunch. We've created reverse score items. We did split half reliability, Chromebacks reliability, and then created this average of all the items here so we could see the mean, standard deviation and the relative distribution of all the items. And when it comes to doing your paper, you're not going to describe the distribution. Basically what you'll do is you will just describe the mean and standard deviation of your total scores, and then say, figure 2 or 3, whichever figure you're at that point, and then in that figure, you will show your distribution graph. So don't worry about having to describe whether or not it's normally distributed. I'm just sort of talking about that just so you can benefit from knowing why we're looking at this graph. But when you're doing it in your actual paper, you'll just show the graph. You're not going to have to describe it or say whether it's normally distributed or not or anything like that. So that's everything you need to know to do this lab homework for the week, and also to analyze your data once we have that back from your all your survey items.